Yes, sir.
Okay, so let's resume the presentation.
Take our attention to celestial sphere diagram.
Are you able to see it clearly, beta?
Yes, sir.
Right. So what we had discussed is we discussed the rational horizon, NESW. We saw that Z point will be exactly in the center. Then Z to Q, the red highlighted portion, will be the latitude of the observer. WQE is the equinoctial. P is the pole, the north celestial pole in this case. Then P to Z, the yellow highlighted portion, is 90 minus latitude or colat. So we had done up to here. Now proceeding ahead. Next thing what we are going to discuss is this vertical circle which you see, Z to X to H. So this vertical circle is what we are going to show in the rational horizon diagram now.
From the Z point, if you draw a vertical circle passing through the body is here, that is star X. So from the zenith, if you draw a vertical circle passing from the body, going up to the rational horizon to point H and going up to the nadir, this is the vertical circle passing from the body. Now, if you look from top, this vertical circle is also going to look like a straight line. And how will this look? From the zenith, you see this particular dotted line. This is how this vertical circle is going to appear. The point where this vertical circle touches the rational horizon, you see the vertical circle from Z going up to X touches the rational horizon at point H. This point H is going to be this particular point here. From the zenith going up to the rational horizon, this is the H point. Again, somewhere in between the Z and H points, you will have the celestial body, that is the star, which is represented as X here. So let's mark the celestial body also now in our rational horizon diagram. So somewhere between Z and H, we will have the celestial body shown here in the rational horizon diagram, represented by X. You can see the celestial body here. Now you can see H to X is the true altitude of the body. So concentrate on the celestial sphere diagram. You see X to H highlighted in the maroon color. You have the true altitude of the body. The same true altitude is represented H to X in the rational horizon diagram. So let's mark it with maroon color, highlight it with maroon color here also in the rational horizon diagram. Now going back to the celestial sphere diagram, you see Z to X. This is the true zenith distance of the body, which is 90 minus true altitude. So let's show it here, Z to X. Let's highlight it also with the green color. You see Z to X is the true zenith distance of the body, and it is equal to 90 minus true altitude. Another important thing in the rational horizon diagram, you see the zenith is at the center of the rational horizon plane diagram, and The circumference which you see of this particular diagram is the rational horizon of the observer. Now we know every point on the rational horizon is 90 degree away from the zenith. So this indirectly tells us that the radius of this particular diagram is 90 degrees. That means from Z, if you go to the rational horizon in any direction, it will be a 90-degree arc. So from Z, if you move towards H, Z to H is total 90 degrees. H to X was the true altitude of the body. That tells us Z to X, that is the green highlighted arc, will be equal to 90 minus true altitude. You can compare it with the celestial sphere diagram also. Z to H, zenith to horizon, was 90 degrees. H to X was the true altitude of the body, and Z to X is equal to the true zenith distance, which is 90 minus true altitude.
So this is clear, beta, up to here. Any doubts?
No, sir.
Okay, very good. Let's proceed ahead then.
So we have two sides of the PZX triangle now plotted in our diagram. Let's move on to the third side now, that is P2X. So this third side, which is P2X, going further to the south celestial pole, is the celestial meridian passing through our star. So we have to basically draw the celestial meridian of the star. So pole to X. So let's come back to the rational horizon diagram. This is the pole, and this is the celestial body, the star X. And we have to draw the celestial meridian now. So let's draw it. This celestial meridian is going to appear like this. This is how the celestial meridian is going to appear. So you see, passing from the pole, going further up to point X, and eventually going up to the rational horizon. This represents the celestial meridian of the body.
सर ये भी स्ट्रेट लाइन दिखनी
Now
चाहिए
the
ना सर
celestial meridian of the body.
सर सर ये भी स्ट्रेट लाइन दिखनी चाहिए ना
नहीं बेटा, ये स्ट्रेट लाइन नहीं दिखेगी. To give you an example, it is actually why it is not a straight line is because we are trying to show a curved 3D surface on a plane screen. अगर आपको याद हो बचपन में बेटा ड्राइंग की क्लासेस में खरबूजा बनाते थे ना, स्वीट मेलन.
जी सर
तो वो खरबूजे की जो लाइनें होती थी, यू रिमेम्बर, एग्जैक्टली ऐसे ही दिखाते थे हम वहाँ पे. All coming from the center, going in different directions. So that's how we show them here. They will not be straight lines, they will be curved lines. Are you getting it, beta?
जी सर बट मेरे को लग रहा था कि जैसे हम इसको ऊपर से देखेंगे तो ये भी स्ट्रेट ही दिखाई देगा
बेटा
जेनिथ के
हमारी
ऊपर
जो
से देख
ओके, लेट मी टेल यू. हमारी जो आई है, आई ऑफ द ऑब्जर्वर, दैट इज डायरेक्टली ऑन टॉप ऑफ द जेनिथ.
जी
अगर
सर
जेनिथ से कोई भी रेडियल लाइन बाहर जाएगी वो तो स्ट्रेट दिखाई देगी, लेकिन जेनिथ को छोड़ के किसी और पॉइंट पे अगर आप ग्रेट सर्कल ड्रॉ करोगे तो वो स्ट्रेट नहीं दिखाई देगा बेटा. ये जो वर्टिकल सर्कल है, ये एक्चुअली ग्रेट सर्कल पासिंग फ्रॉम द सेलेस्टियल पोल है. इफ यू आर लुकिंग फ्रॉम टॉप ऑफ द पोल, लेट अस से आप पोल के ऊपर से इसे देख रहे होते और पोल हमारे सेंटर पे आ जाता है, इस डायग्राम के सेंटर में, In that case, all the celestial meridians would appear as radial lines. उस केस में ये सीधी
ठीक
दिखाई
है,
देती.
ओके सर,
Are you
समझ आ
able
गया.
to visualize?
यस यस सर, इसको हम ऊपर से नहीं देख रहे बिल्कुल,
Right.
क्योंकि
हमारी जो आई है वो है जेनिथ के ऊपर.
ठीक है सर.
Right. Okay. और बेटा, any other doubt till now?
नो सर.
Okay, great. Let's proceed ahead.
सर तो इसमें MZD क्या अगर दिखाना होगा तो क्या दिखाएंगे?
Okay, उस पे आते हैं बेटा. Just reserve this question with you. Let me finish making this diagram, then I'll tell you MZD कहाँ पे आएगा.
ओके सर.
Okay.
Cuts the WQE line. WQE line is the equinoctial at point D. Now you can look at it in the celestial sphere also. Celestial meridian from the pole going up to the body X goes up to the equinoctial at this particular point. So this point here is the D point referred to in our rational horizon diagram. This is the D point in the celestial sphere diagram, and it is referring to this D point on the rational horizon diagram. Going further from D, at this point, it crosses the rational horizon. And if you see here, going further from D, it reaches this particular point, it will cross the rational horizon and go on the far side. So we have the celestial meridian of the body drawn now. Now let's mark off on the celestial meridian. From the equinoctial up to the body D to X. This basically represents the declination of the body. How much north or how much south of the equinoctial a particular body is what is its declination. So the arc of the celestial meridian contained between the equinoctial and the center of the body is the declination of the body. So dx is the declination. You can correlate it in the celestial sphere diagram also. D point on the equinoctial, X point, the celestial body, D to X is the declination. Now coming back to D point in the rational horizon diagram, we know from the equinoctial, that is D point, to the pole, that is P point, is always 90 degrees. Every point on equinoctial is 90 degrees away from the pole. So D to P or P to D is 90 degrees. D to X is the declination. That tells us that P to X will be 90 minus declination. The arc which is highlighted in maroon color now, it will be 90 minus declination, and it is the polar distance of the body. You can correlate it to the celestial sphere diagram also. You see, D to X was the declination. X to P is the polar distance, which is 90 minus declination. So you can see now all the three sides of the PZX triangle shown in the rational horizon plane.
Now have a good look at this diagram, beta. Let me know if any doubts. All clear?
Yes, sir.
Okay, all right. Let's proceed ahead.
So as you can appreciate looking at both these diagrams, that diagram made on the plane of the rational horizon is much simpler and easier to make. And you will be able to make it in much lesser time as compared to the celestial sphere diagram on the left hand side. So this is the reason why we use the rational horizon diagram so diversely, so randomly to solve the celestial navigation based problems. Now, beta, going little more deeply into the PZX triangle, we have seen all the three sides of this triangle. One side, the PZ, the yellow color side, is the colat, which is 90 minus latitude. The green color side, ZX, is the true zenith distance, which is 90 minus true altitude. And the maroon color side, which is PX, is the polar distance equal to 90 minus declination. Now, we are also able to identify and find out two of the angles of this particular triangle. Now, the first angle here, which we see or which we are able to easily correlate and find out, is angle P in this PZX triangle. Now, if you look carefully, the line PZQS represents the meridian of the observer, the celestial meridian of the observer. So pole to zenith to Q point to S point represents the celestial meridian of the observer. And if you see the side P to X to D, this particular side is the celestial meridian of the heavenly body of the stars. So this particular angle which you see here, that is angle P, is the angle between the celestial meridian of the observer and the celestial meridian of the body. And this angle is being measured in this particular direction. So you are measuring this angle in this particular direction, which is this direction. This direction, you can have a look here. This represents the westerly direction. The right side in this diagram, this part you see here represents the easterly direction, and this side represents the westerly direction. So angle P is the angle at the celestial pole contained between celestial meridian of the observer and the celestial meridian of the body measured westwards. This is the definition of LHA, local R angle of the body. Angle at the pole contained between celestial meridian of the observer and the celestial meridian of the body measured westwards. So this angle is the LHA. So we have identified angle P of the PZX triangle. Let's move on to another angle now. Let's concentrate our attention on angle Z. Now, if you look at angle Z, this is the angle between the celestial meridian of the observer. You see PZQS is the celestial meridian of the observer, and the vertical circle passing from the body. Now this angle is the azimuth of the body. So let me represent it in blue color. You can see this particular angle here. This is the definition of azimuth. So the angle between the celestial meridian of the observer and the vertical circle passing through the body is the azimuth of the body. You can visualize here, beta, the angle. This angle basically gives us the direction in which the body is. The side PZ or NPZ represents true north, and the side ZX represents the direction in which the celestial body is. So you see, this particular angle tells us what is the direction of the body with respect to true north. And if you look little more carefully, you will understand that this is the quadrantal azimuth of the body, or the azimuth of the body in the quadrantal notation. In this particular case, the body is northwest of the observer. You see, this is the endpoint represents the north direction. The W point represents the westerly direction. So this body is somewhere in a direction northwest of in the northwest quadrant of the observer. So the azimuth which this angle Z gives us is the quadrantal azimuth of the body. North so many degrees west is the azimuth of this particular body. So we have identified angle Z in this triangle. So these are the two angles which we can find out in this PZX triangle. So two angles have been identified and all the three sides have been identified.
Any doubts up to here, beta? Okay, all clear till now. So let's proceed ahead then.
Yes, now the only unknown item which we are not interested in, that is angle X. This is the angle at the celestial body. We do not use this angle in our calculations, nor can we find it from this diagram. We don't require it. If we need, we can find it, but we don't require this angle anywhere. So this angle is usually left unknown, and neither it is used nor it is found out. This angle is not required in the calculations. So we have the PZX triangle understood. We have understood all the three sides of the PZX triangle. We have seen the two angles of this particular triangle.
Okay, beta, have a good look at this now, and any doubts you are having, just let me know. You can have a screenshot of this screen and keep it with you. This will immediately give you an comparison between the celestial sphere diagram and the rational horizon diagram. Also, PZX triangle is explained here, so you will have all the parts known to you.
Yes, sir.
ले लिया सर स्क्रीनशॉट्स.
Okay, all right.
Now we have understood the PZX triangle well. We have seen the three sides. We have seen the two angles. If you look more carefully on this PZX triangle, you will see that this triangle is a spherical triangle. This fulfills the condition for a spherical triangle. It is made on the surface of a sphere, that is the celestial sphere, and all three sides of this triangle are arcs or parts of great circles. You see, the PZ side is part of the celestial meridian of the observer. The PX side is part of the celestial meridian passing from the body. All the celestial meridians are parts of great circles. All celestial meridians are semi-great circles. Now the third side, which is the ZX side, is the part of the vertical circle passing from the body. All vertical circles are also semi-great circles. So this triangle, the PZX triangle, is a spherical triangle because it is made on the surface of a sphere, which is the celestial sphere, and all three sides of which are arcs of great circles. Now, how do we use this triangle in celestial navigation questions? Now, in any celestial navigation question where this triangle, PZX triangle, is to be used, you will be provided with some information. So we draw the rational horizon diagram, and whatever information is provided to us, that is fed into the diagram. We note it down, we label the diagram accordingly. Whatever information is provided to us is put in the diagram. And as you put this information, you will see that out of these 5 parts which we have discussed here, out of the 5 parts which we have discussed here, that is the 3 sides and the 2 angles, you will be given some parts of the triangle, and using those parts you will be able to find out the other parts of the diagram or the triangle. So how will you be finding them? Using the same spherical trigonometry formula which we have used for other calculations, that is the cosine formula and the Napier's rules. Since this is a spherical triangle, cosine formula and Napier rule are applicable here, and whatever information is provided to us, it will either allow us to use it in cosine formula or in the Napier rule, and we will be able to find out everything else. The remaining part, whatever are missing, can be calculated using cosine formula and the Napier's rule. So this is the concept which we used in rational horizon based questions. So PZX triangle is a spherical triangle made on the surface of a sphere. All 3 sides are parts of great circles. We are able to identify 5 parts of this triangle, that is the 3 sides and the 2 angles. Out of these, some of them will be given to us in the question. By using the given parts, we apply the cosine formula or the Napier rules, and we find out the missing parts. As you find the missing parts, the question gets solved. So this is the basic concept which we use in solving celestial navigation question. So in the questions, now you will be using the rational horizon diagram, which is given on the right side of the screen. The diagram which is given on the left side of the screen, which is also called as the celestial sphere diagram, is not used as it is much complicated. So we will not be making the celestial sphere diagram now. I made both of them to make you understand their correlation with each other, so that you are able to understand the basic concept behind it. Now, once understood, we don't need to draw the celestial sphere diagram. We will be using the simplified version, that is the rational horizon diagram, and solving our questions. So a very, very important concept of rational horizon. The explanation is completed now.
Now, beta, someone asked in between about the MZD, meridional zenith distance. So we can see this MZD also in this particular diagram. Now, let's say we are discussing about this star only. MZD is the meridional zenith distance. The meaning of MZD is The zenith distance of the body when it is on the meridian of the observer. So if you want to find out the MZD of this particular body, right now the position where it is not on the meridian, it is at X. Our meridian is PZQS. This is our meridian. So right now the zenith distance which you will be getting will be the TZT. That is why it is mentioned as TZT in the diagram. If you want to find that what was its MZT when it was on the meridian, we can also do that. Now for this, we will need to draw the declination circle of the body. So how can we draw the declination circles? All declination circles are parallel to the equinoctial. You see, equinoctial is the WQE arc which we see in the diagram. So if you draw an arc parallel to WQE and passing from X, it will appear something like this. Right, beta? Are you able to see the motion of my cursor?
Yes, sir.
Yes, sir.
So this is how the
सर पर ये
declination.
नेट जेड के नीचे जाएगा या फिर जेड के ऊपर से पास होगा, वो कैसे पता लगेगा?
हाँ बेटा, वो अभी हमें पता नहीं चलेगा। अगर तो उन्होंने हमें बॉडी की डेक्लिनेशन दे दी है और ऑब्जर्वर का लैटिट्यूड भी दे दिया है, तो फिर हम आसानी से पता लगा सकते हैं। इफ द डेक्लिनेशन इज हायर देन द लैटिट्यूड, in that case the declination circle will pass north of Z, and if the declination is less than the latitude, the circle would pass south of Z.
ओके सर.
Okay. If it is not given to us, one of these two items is not given to us in the question, then we will have to make a rough diagram. We don't need to make a to the scale or fair diagram for rational horizon. The rational horizon diagram is always a diagram which is non-scale diagram. So you can show it anywhere, make the PZX triangle, calculate the missing part, whether declination or latitude. When you calculate it, you will be able to find out how to make the declination circle of this particular star.
ओके सर.
ओके बेटा, ओके। और बताओ बेटा, और कोई डाउट इस डायग्राम में?
सर आपने एमजेडी क्या बताया सर इसका डायग्राम?
ओके, you want to know MZD beta? What is MZD?
Yes, sir.
Okay, I'll tell you. So I left in between. So anyway, when you draw the declination circle of this particular star, okay, let's say the declination circle goes like this. When you draw the declination circle, the point where it crosses the meridian, let's assume it crosses the meridian somewhere between Z and Q. So this is the point where the body will be, celestial body, at the time of its meridian passage. So from this point up to Z, this represents the MZT of the body, meridional zenith distance.
It will be also sir north south also.
Yes beta, certainly. Whether the MZD की तो कोई डायरेक्शन नहीं होती, like true altitude doesn't have any direction. The TZD and MZD also doesn't have any direction, but we can certainly find out whether the body will pass north of the observer or south of the observer. That we can do comparing the latitude and the declination of the body. Okay, just to give you an example.
Sir, from there we can make this diagram, no sir? If MZT is calculated.
Yes, from the latitude and declination, you can find out whether the body will pass north of you or south of you, and then you can make the declination circle of the body also. Just to give you an example, what is the declination of sun beta nowadays approximately? Is it north or south?
South.
Okay, very good. So the declination of sun is south, and let us say we are sitting in the northern hemisphere. Let's say our latitude is 30 degrees north. So our latitude is almost similar to the one which is shown in the diagram. So zenith will be here, equinoctial will be here. Let's assume the declination of sun is 5 degrees south. So it means the sun is 5 degrees south of the equinoctial. That means from the Q point, if you go 5 degrees southwards, this is from where the declination circle of sun should pass. So you can draw a circle parallel to the equinoctial passing from this point. It will appear something like this.
सर एक डाउट और था सर जैसी कोई भी मतलब एक तरीके से डेक्लिनेशन सर्कल पे जो सेलेस्टियल बॉडी है और वो WZE1 लाइन से नीचे आएगी, ये जो है सर WZE जो डॉटेड लाइन है, तो इट इज बिलो अवर होराइजन, मतलब वी कैन सी इट और नॉट सर?
बेटा जो WZE लाइन है, it has got nothing to do with the horizon. It's not the horizon at all. हमारी
ओके
horizon
सर.
है NESW. This is our horizon.
ओके,
So anything which you see in this circle,
वी विल बी एबल टू सी.
we will be able to see.
ओके सर.
Okay.
ये celestial sphere के diagram में if it is below the north south तो उसके नहीं देख पाएंगे ना सर?
Right. If you come to the celestial sphere diagram on this side, if a body has gone below this NESW circle, let's say the body has come here, तब वो आपको नहीं दिखाई देगी. So ये जो bottom वाला part है, this part of the celestial sphere diagram, which is below the rational horizon, is not visible to us. So if the body is somewhere here in this part, it will not be visible. If it is on the top half of the celestial sphere, then it will show up in this diagram, NESW rational horizon diagram. It will show up somewhere. Okay. Or doubts, beta? More doubts?
सर रैशनल होराइजन डायग्राम ऐसे का ऐसे भी याद रख लेंगे तब भी सही है सर, है ना?
हाँ
ऐसे
बेटा,
रैशनल
सारी चीजें इसमें कवर अप हो गई हैं. सो अगर आपको ये
ठीक है
पिक्चर डायग्राम याद हो जाती है, सेलेस्टियल
जी
नेविगेशन इज
सर,
डन.
ठीक है सर.
हाँ.
ये सर वैसे तो आ गया है, समझ में आ गया है सारा.
Right, beta, right. Good. So if you have understood this concept, then a great concept in cell nav is gone in your brain. And
सर
इससे
ब्रेक
ज़्यादा इससे ज़्यादा डेप्थ जो है वो सेल nav में नहीं चाहिए. If you have understood this much, that means you have touched the bottom. So बाकी के questions में तो हम सिर्फ इसे use करेंगे. If the understanding is there, then all those questions will be very simply done. Okay.
सर नेपियर रूल के लिए सर 90 डिग्री एंगल अपना फिर इसमें ये होगा तीसरे वाला.
अब मैं आपको एग्जांपल्स बताता हूँ कि नेपियर रूल
जी
यहाँ पे
सर.
कब अप्लाई हो सकता है. See,
जी
one
सर.
thing when Napier rule can be applied is when the altitude of the star is zero. अगर स्टार का एल्टीट्यूड जीरो हो जाए तो आप देखोगे जो ये ZX साइड है ये 90 डिग्री हो जाएगी. राइट?
यस सर.
एक तो ये पॉसिबिलिटी है. दूसरी पॉसिबिलिटी है कि जो ये स्टार है इसकी डेक्लिनेशन जीरो हो जाए. If they give you a body whose declination is zero, so you will see जो PX साइड है ये 90 हो जाएगी. राइट?
यस सर, करेक्ट.
और तीसरी पॉसिबिलिटी ये है जब आप नेपियर रूल यूज कर पाओगे if the celestial body is on WZE line, anywhere on this line, अगर वो आपको बोल दें कि जो celestial body है it was east of you और it was west of you, तो आप देखोगे कि जो azimuth है ये angle Z ये 90 डिग्री हो जाएगा. So again Napier rule can be used here.
ठीक है
Right,
सर.
right beta. These are the three conditions in which you will be able to use the Napier rule. And जो ये WZE line देख रहे हो आप, it is basically a vertical circle passing from east and west points, and it is also known as prime vertical circle. WZE is the prime vertical circle. और जो ये vertical line देख रहे हो आप N to Z to S, this is also a vertical circle, and इसको हम लोग नाम देते हैं principal vertical circle. So NZS, vertical circle passing from north and south point, is known as the principal vertical circle, and WZE, the vertical circle passing from east and west points, is known as the prime vertical circle.
ओके सर.
सर तो इसमें जैसे सन का डेक्लिनेशन साउथ है तो वो तो WQE के नीचे आ जाएगा अगर हम फिगर बनाएंगे. तो
That's right, beta. The declination circle would be like this somewhere.
पोल हमेशा लैटिट्यूड के हिसाब से यूज करेंगे. अगर नॉर्थ लैटिट्यूड है तो नॉर्थ पोल यूज करेंगे डायग्राम बनाने.
That is right, beta. Pole will always be according to the latitude.
ओके.
Okay, great. So we have understood this concept. So अब बेटा हम इस concept के बाद now we will be moving on to the next topic. पहला topic जो मैं अभी आपके साथ करूँगा based on this is the star identification. So in this we will see how to identify the stars. When we take a star site, there is a requirement that you need to identify the star. So we are going to see how do we identify these stars using the concept of rational horizon diagram. That's what we are going to see. Now for that you need to refresh the altitude corrections. Okay, मैं भी ये altitude corrections आपके साथ cover करूँगा, but that is part of our second monthly module. So when new candidates join in after 15th, so then I will start off with the altitude corrections and all the 5 side solving methods. So अब इसको करने के लिए I would tell you guys to practice the altitude correction topic. So प्रैक्टनैप बुक में हमारे altitude correction topic है जिसमें हम sextant altitude को correct करके true altitude निकालते हैं. उसमें हम corrections लगाते हैं, index error, dip correction, total correction. Okay, so I want you to revise that topic. उसमें भी दो ऑप्शन होते हैं. You can apply the corrections individually, separately. Refraction, semi-diameter, parallax, that is a difficult method. Second option is you can apply the corrections as total correction. So don't go into individual corrections, that is not required. Just revise the total correction method. So maybe you can practice one question of sun, star, planet and moon, correcting their altitudes. You will find them in the PracNav book. A lot of questions are there. So just practice this concept, and once it is clear in your mind, we move ahead to star identification topic. So with this star identification topic, basically हमारा module 1 का जो syllabus है वो खत्म हो जाता है. So we have time. So once this is completed, then in the second module 15th onwards, we will be starting off with the familiarization with the almanac, the site solving and plotting. So this is the plan going ahead. So we will stop it here for today. You practice the altitude correction topic, and next session we will start off with star identification.
सर अभी
ट्रायंगल पर जो न्यूमेरिकल है वो बाद में करेंगे.
Which one, beta?
Sir, numericals is question based upon PZX triangle.
ये सारे PZX पे ही बेस्ड हैं बेटा. स्टार आइडेंटिफिकेशन इज बेस्ड ऑन PZX. ये आते जाएंगे.
सर अभी कितने बंदे आने वाले सर? और 15 से
बेटा
कुछ
अभी
है?
मुझे इंफॉर्मेशन तो नहीं है. आई विल गेट द इन्फो इन 3-4 days. So we are total how many guys?
29 है सर, शायद 29 होंगे हम.
29. So
29 या
11 और
27.
capacity है बेटा. 11 people. We have a capacity of 11 people. So let's see how many come.
ओके सर, कोई बात नहीं.
Okay. You will still be in majority.
नहीं सर, बस ऐसा ही पूछ रहा था.
Okay. Okay. So let's break off for today and we continue in the next session.
Thank you, sir.
ठीक है सर, थैंक यू सर.
Okay, beta. Thank you. Bye bye.